Welcome back to the Pioneer STEM Show. Okay, Mr. Saka is with us now with this amazing looking setup. What is this thing, Mr. Saka?
Okay, it is a surveillance robot which is aimed to be used in the petroleum industry for surveillance.
Okay, so if someone should ask you, what does it do? What is it use?
Okay, let's say it's as I've said before, it's mainly used whenever surveillance and security is needed, which it can move around. But now it is controlled with on a mobile app. But in the future, I aim to use an autonomous system in it, which can move around by itself with some sensors. With a sensor like we have LiDAR, which can which you can use to determine what is around it
Light and radar.
by mapping. Yeah,
Okay,
you know how mapping works.
yes. So if, let's say someone gives you $100,000
Okay.
to work on this product as a product, not a prototype, what features would it have? What would it look like? What will it be able to do?
Okay. It will be able to detect any pipeline issue automatically, then send feedback to the system from anywhere in the world. Then we embed IoT into it, so it can work, can be accessible from anywhere in the world, and be able to fix some that it could fix and avoid obstacle by itself and work autonomously.
Amazing.
That's the main aim.
Amazing. So I could think of so many industries this will be useful in.
Useful.
Aviation is one of them. You know, there are parts of an airplane where you can't get to that need maintenance. I see this being of great use, albeit it's been smaller, you know. So I'm curious to know, how did you come up with this idea?
Okay, I'm an object-oriented person. So I look at problems around me and develop a solution for it. And this one is part of it. And I know this will be very useful in industry like this, and we help them eradicate human error and as well as prevent injuries from how will I say it, places that can't be reached or places that are very dangerous. So that's how I came up with this innovative idea to help mitigate all those problems.
Amazing. So walk me through because you're going to be showing us how this works.
Oh, okay.
We want to see this. But
Okay.
how did you come up with this? Walk me through from the design process to this prototype. How did you get here from design?
Okay. How it works is I have the system which controls the motors. I use Arduino Uno for it, which is the microcontroller which controls everything.
Okay.
It works with Bluetooth and connects with my phone. So I use a mobile app for it to control it. So whenever I connect with it, it will control the movement forward, backward, left, and right. So we have a Bluetooth module which connects with my phone, as I've said before, and we have a different system which is the surveillance part. And I use ESP32 cam. I know you're familiar with it. I use ESP32 cam which connects with my phone hotspot. Then I connect it with either my phone or my system. It can be viewed on various devices. So I connect it with it, and it shows me the live event, the video of anything that is going on at that place. So just think of it, if this could be doing this at the prototype stage. So what if we get more fund? I get more fund to build it. You see how advanced it would be, and would be very helpful in Nigerian industry, petroleum industry.
Amazing. So I'm seeing a screen here. This is an LCD, right?
Yes.
What are you displaying on this
Okay.
robot?
The display is just to display the progress of the robots. You know, this could be outside, and the people that are inside. Though the people that are inside will be getting the live feedback from the camera.
Okay,
So
there's a camera on this.
there's a camera on it.
Okay.
You can see from this O, like this O, there's a camera inside this O,
Okay.
which will be used to view on the place around it. So that LCD screen is just to give the feedback to people that are around it when moving forward. When it need helps, you know, it could be in front of an obstacles now. Then we now send message from the mobile app to the screen. So maybe help me or something.
Okay, someone can read
Read from the LCD screen. So it works like that.
This could be useful for deliveries as well.
It's useful for delivery.
There are so many opportunities for this.
Exactly.
This is fantastic.
So if we can employ a GPS module or for it, it can be run around the.
So this is even scalable. So
It's scalable. So
fantastic. So tell me the programming. Hardware is hard.
okay.
Software should be soft. Explain the
We use
software part.
We use Arduino programming platform for it, IDE.
Okay.
So it runs with C++, and it can run on Python too, MicroPython, about its ESP bots. But this robot itself work on C++, and which is the one we use to control it. So the programming just goes like this. If it receives a message from this mobile app, F is for forward,
okay.
B is for backward, and R is for right, L is for left. So whenever I receive the message from this mobile app, it will use that to move forward, backward, sideward, left and right. So that's how it works.
Amazing. This is a job well done. I'm a tech creative myself, and I know the headache that comes with hardware, especially. So
exactly.
What challenges did you face building this beautiful piece of art?
Okay, say the design part, how to make it more smaller, and the fabrication part. So I was looking for things to fabricate it. So I stumbled on this, and I feel like this will be the best to fabricate it, because it's waterproofed, and it can be made much more waterproof than this. So the weather condition at the site it will be surveilling could be very dangerous to it. So this will protect it from the conditions.
Amazing. Let's see this baby work.
Okay. We'll on it from here, then on this one too. There's two different systems entirely. Okay. Then I will connect from my phone. I'm trying to connect to a car right now. So we have the Bluetooth here. It's using Bluetooth technology.
Okay.
So
does that mean the range is limited?
The range is limited. That's why I said it can be made much more than that. So it's now connected. Let me move it forward. So that's how it moves sideward. That's right, and that's left. So this is front, and this is back.
It's very responsive.
Very, very responsive and very fast too.
Amazing.
So if you put it down now, to run very, very fast.
So I imagine this is a pipeline.
Okay.
It's just going through it.
Okay.
With its camera, right?
Okay. For a pipeline, it will even be smaller than this. And one good thing about this thing is every component is detachable. So it can work independently. Like this one now, it can be removed from each other because it connects via Bluetooth, all of them. So it can be detached from each other.
Even for transport, for portability.
For portability. So let's say we want to use this in food or maybe drug delivery. That can just be removed from the box. We can add a third box. We can add as much as it can work with. Can add those boxes there for it to work.
That pretty much increases its versatility.
Yes.
You could just remove this and put a basket.
A basket.
Amazing.
Removable.
Well done, Mr. Saka.
Thank you very much.
Done. So this project, was it a personal project or did you work as a team?
Yeah, this project is a personal project. Most of my projects are done by me only. So
what other projects have you worked on in that case?
I've worked on many projects. I could remember one that I presented in a competition about 1 month ago, which is a cattle intrusion protection system. So in Nigeria, we know we have this problem of herders and farmers conflicts, and we look into that problem. We develop an innovative solution for it to prevent or to mitigate the problems. So the system works with ultrasonic sensor. It's measured. It detects intrusion in the farm, and whenever it detects any intrusion, it triggers an alarm which chases away the cattle, as well as sending notification to the farmers from wherever he is in the world. I use IFTT IoT platform for it, which can be accessed on our mobile phone from anywhere in the world. And whenever there's intrusion in the farm, it sends information to the farmer, and we have the camera system to which work as the feedback system. It sends images of the events to the farmer.
Amazing. It's incredible the beautiful and intelligent minds we have in this country, creating Nigerian solutions to Nigerian problems. Thank you for joining us on the Pioneer STEM Show. Thank you, Mr. Saka.
You're welcome.
Such a delight to meet you. I am so inspired.
And I'm so glad to be here.
This is still the Pioneer STEM Show. We'll be right back.